Hey folks, so I watched this video of a presentation by Gousto at reInvent, and I thought it was a really interesting presentation, so I wanted to just kind of talk about it and share it with you guys. It's pretty long. You should definitely watch it. It's like an hour long, but it's really good information in there, and I thought I would just comment on it and kind of highlight what I liked about it. So, first of all, what I like is that it's a it's really just a good use, and there's a lot of use cases in it. But what I like is that it's particularly good use of industrial data to solve practical problems on the shop floor. There's so much data generated in factories, and a lot of times, we don't know what to do with it or how to use it or what the value is, but we know there's value there. And this is just a really simple example of how they did it, and I like these problem solving, continuous improvement examples. So first of all, what's Gusto? They're basically I've never used them before. I think they're in the UK, but they're a meal prep service. So they put together boxes of ingredients for you to cook for yourself. And one quote comes out from them that I really liked, which was, "If you knew the state of everything and could reason on top of that, what problems would you solve?" And I think that's kind of it's kind of inspiring, like they say in the video, and it unlocks a new way of thinking, because I'm all about continuous improvement, and to use this kind of as a jumping point is really nice. So the problem they have is basically they need to ramp up production. They have to basically create a box of food every 3 seconds. So there's like 200,000 boxes a week, and there's about 50 unique ingredients per box. So it's quite the challenge. And they have a good deal of automation. They have these totes moving around the facility, and they're going on these conveyors, and they're going through these picking towers and so forth. And so they needed to basically increase their productivity. So how do they do that with this sort of mechanized situation? Well, they ended up using the OEE metric to kind of point them in the right direction. And the OEE metric gets a bunch of crap, and I understand it because, again, it doesn't solve anything, but they used it to solve something. So I think this was actually a great use of OEE. It told them that of availability, performance, and quality, the thing that they needed to focus on was availability. So great, throw OEE away. Now we know that we want to fix availability. They basically had a 70% availability, and their goal was to increase it to 95. So what's happening with their availability? Why are the machines not running when they ought to? So to do that, they took a pretty straightforward approach, which was, we're going to detect downtime fast. If we want the machines to be up more often, then why are they down? So what do they currently do? So they looked at it, and basically they said what currently happens is, if equipment goes down, or if there's a box is jammed or whatever, then an engineer or someone will have to physically see this is down. Then they'll have to go find someone and tell them to fix it. And then that person will have to go over there, fix it, and then they'll write it in their maintenance system. And that's just the way it works. And it's kind of backwards, because what you want to do is change that up. So what they really wanted to do was, once the machine is down, if we can know this by a sensor, then we want to detect that and then trigger someone to go act on it, and then fix it. And that's kind of common sense, but you can use technology to enable that, and that's what they did. But they didn't have any of the pieces of this puzzle. They have to first, and they kind of laid it out nicely. They said, let's see if I can just quote them here.
And we reasoned that, first of all, we have data in our assets. We need to somehow get hold of it. Once we connect to it somehow, we didn't know how, we need to take it somewhere else and make it better, make it usable, useful to other functions that are going to use it. And once we get it there, we can then start shifting it into systems that can reason on top of that data and start adding value. And more importantly, turn this into actual decisions that we can apply, hopefully optimal decisions, not just decisions. Turn this information into commands back into the factory so that we can control it, alter its state to our favor, and then start preventing some of these problems we were facing.
But anyway, so they wanted to get an engineer to the precise location and the precise fault as soon as possible. Straightforward. So how do they do this? Well, They took they had this data on PLCs. They needed to get this, and the way they got this data, well, first they tried doing this manually to get the data to a place that they can make use of it, and they tried to do this on their own. For a year, they tried to build a system that could do this, and according to them, they failed. And eventually, they found HiByte, and HiByte is a wonderful product, so great for this sort of stuff. They talk about how important it was to them here, and I actually know a couple people at HiByte, and it's a great team too. They're really good people. So great product, great team. They found a ton of use with HiByte, and it opened it up for them. So what happens is HiByte is taking in this data, and then when they notice there is an issue with one of the machines, it triggers a Lambda function of some kind, hits the API, goes to their CMMS, and then suddenly they get a person over there. And this act alone drove down their ability to respond quickly. But beyond that, it does all kinds of other stuff too. Like what it did was it let them see the entire workflow. So it's not just the time it takes for them to recognize that there's an alarm. Then it says, well, how long does it take us to respond to that alarm? And then how long does it take us to solve the problem? And then, and so on and so on. So they get every little detail there. And it's really powerful. So they talk about this in greater detail, but what it won for them was the ability to basically respond rapidly, react more quickly to solve these problems. And that's the name of the game. That brought them just a huge amount of savings in terms of availability. But beyond that, they talk about other things that they can do, like with this data. Now they can actually look at higher levels of analysis. So they started putting the data in a data lake. They're able to look at patterns at a larger level. They can run some machine learning on this stuff, and they can see, of all of our facilities, which facilities should we invest in, for example. So they have larger, higher order strategic dashboards and things like this. And now that they have this data, they can do more stuff with it. So they talk a little bit about preventative maintenance. What they do here basically is they've got this one part of their building that's kind of like really critical. If it goes down, everything sort of stops. So they put some sensors on it, and they sent that data into I should also mention, all this was put on a UNS, which was really enabling for them, because that now that the data goes from HiByte to the UNS, they're using IoT Core from Amazon. That MQTT broker makes it very easy for them to ingest it into systems like this one. And this one is basically a predictive maintenance anomaly detection. So when this thing is having excessive vibration or temperature, it automatically goes right back and signals a work order. So now the maintenance personnel, it just shows up in their work queue, and they're able to go ahead and act on that. And that saved them some actually critical downtime events. One of the things they noticed, they fixed the fault. It didn't actually stop the machine, but it would have stopped the machine for something like 4 hours, which would totally crush them. So really good work there. Other things they can do now that it's in the UNS, they can really quickly pipe it into a SCADA system. So they built a SCADA system. They used Ignition. I've never used it. I've heard good things. I would use Tulip, because Tulip is awesome. But they use Ignition. The SCADA system that it came with, their big automated system, was basically just like 10,000 lights, green or red on a screen, and it wasn't that actionable. So here they were able to create something that was a little more compelling, a little more user-friendly, and something that they could, interact with. And when a fault happened, whereas with that array of 10,000 lights, it didn't even tell you where it was failing or what was failing for. It was just go figure out what this light is. And here it's literally a map of their facility. They can see exactly where it is and why it's down and so forth. So really neat stuff here. There's more stuff in here, like they did modeling and all this kind of stuff. So this is a great example. I would totally follow it, but I just wanted to share what I liked about it, because it's like a practical example of using data to solve problems. And this is a kind of continuous improvement activity that I think we need to do more often, because I love continuous improvement activities where it's these highly manual processes, a little more nuanced, the gray area that keeps the factory alive. I love that stuff. But this is just a simple, system of solving problems more quickly. So really good video. I hope you watch it.